Yeah, I think we're gonna start with our session today. And I'm also sharing my screen. So here you go. Should be able to see my presentation now. Okay, then welcome everybody to this workshop, Creative Programming with TurtleStitch. My name is Horat, and I'm happy that you're here and want to see something about what we did with our learners and taught them programming with TurtleStitch, and we will have a look at the results from that workshop. Yeah, they created for us, and that gave us an insight into their work. Before we start, I will say something about the principle of programming with TurtleStitch. I don't know what background you have. Some of you are certainly very experienced in TurtleStitch and Snap and other branches. Some may be new. So it's a block-based programming language. You can snap your blocks together, then execute it and see the results directly on screen. And where TurtleStitch goes further, for instance, like in BeagleBox, you can export your program. And in this case, you can stitch your pattern and then have a physical result. As announced or pointed out yesterday in Secret and Surprises in Coding Spirals, this is one very nice thing, as Susan, Cynthia, and Sarah demonstrated. So you can have some physical result and motivate the students, female and male alike. So we're going to our agenda for today, for our workshop today. First, I will tell something about us, about me and my colleagues. Then we will report on the project days, the project we had with our students, the results we got back, the learning cards they created for us from their creative projects. And then we will have a creative phase ourselves. I will demonstrate in very brief, the basics of TurtleStitch, so everyone is on the same page and we can follow the students' instructions from the learning cards and try to analyze what was done properly in the student cards, maybe what could be improved, and interesting things we can learn from this. And we'll of course then discuss and reflect on the students' work, and in the end there will be a brush-up session for questions, and also we will share our experience we gathered in these workshops. Okay, so yeah, we are working for the Swiss University of Teacher Education in the Institute of Media and School. My superior, Mareen Przybylla, head of endowed professorship in computer science education. We are busy in secondary school level material, concepts, projects, and so forth. And I'm for 6 months now a junior researcher in this team in the computer science education. I also want to welcome Julia Paparo, my fellow junior researcher, who is joining us today and helping us. One thing about my first name, it's a bit difficult to pronounce for English tongues. I'm aware of that. It's Beat, but you can call me Beat. I'm used to that. No problem there. Okay. So let's jump into the project days and what we did at the project school that we are often in contact with. We are working with the project school quite a lot. And in this phase, it was a very creative event to introduce the summer break. And we had 2 days. There were different activities. There was a magician, there was hiking and things like that. And we could provide some input in programming with TurtleStitch. So we had a class of lower secondary school students, 14-year-old students. And the entire class was assigned to the workshop. Due to COVID, we couldn't mix and no student could pick a topic they wanted to. Now and there was a bit of a motivational problem, but in general, we could manage and could motivate them to work with TurtleStitch. But that's something we needed to be aware of for the workshop. We split the class in 2 groups of 9 and 8 students respectively, and we had 1 full day of TurtleStitch per group to introduce them to. I was the presenter, Mareen, and the class teacher were helping out with questions and coaching and whatever was important during the workshop and the students needed help with. Okay, the agenda for the workshop we had with the students was in the morning, introduction with examples. So we had some theoretical blocks and let them try out for themselves with the examples. There was free hands-on training with support of support of the teachers, and some further input sequences in between. And in the afternoon, the creative phase, they could choose an individual project. They could stitch the project themselves. We helped them. This was under supervision of the teachers, so nothing could happen with the stitching machines. But everyone could have a physical result they could then put together and hold in their hands. And this was a really nice part of the project and the workshop. They also had a task of creating learning cards that commented their work. So yeah, they had an opportunity to showcase their work, to comment on it, what was important, what was difficult, what they learned about it. And we based these examples on the already existing beginner cards of TurtleStitch. By the way, when I say beginner cards and learning cards, I use these terms interchangeably. And we wanted yeah, to profit from that really great work and these great examples, and let the students make examples, yeah, like examples by themselves. So as said, they can showcase their work, and we in the end could also analyze what they did well, maybe where they had problems, and maybe where the description was not sufficient, or maybe was not on the point. Okay. So these are a couple of examples we photographed. These are the physical examples after they were stitched with the machines. We will discuss some of them today. Some of them we will not see today because they were too complicated, too lengthy code. For example, the one in the middle, the turtle, I really like that one. That one student picked the mascot of TurtleStitch, but unfortunately, yeah, the code was so vast, more or less pixel by pixel. We will not look at this one today, but others we will see in the later creative phase. Okay. But learning materials we used. We had two different documents we prepared for the workshop. It was on one hand, it was a workbook for TurtleStitch. So students could learn and look up and everything what was necessary for TurtleStitch itself. And a manual for the embroidery machine, because it was quite yeah, a long phase to learn to know the machine, some trial and error phase, and we put everything we experienced in that manual. Okay, so for the introductory workbook for TurtleStitch, it could be used as a reference guide during the workshop. It can also be used as a self-learning program for students and educators. So in case some student could not participate in the workshop, maybe due to COVID or whatever could the reason be, due to quarantine, they could learn it at home for themselves. It's example-based and also based on the learning cards. We try to use a similar style in there. So yeah, we could profit from that great work. It's quite detailed and it's quite long, so only extracts will be demonstrated today, and it's available in English and German. You can go to this URL later, and we will use some learning material from that page. We'll paste that link in the chat later. One word about the introduction. About the manual for embroidery machine. We use the Broder Innovis 750E, but yeah, we had this one at our disposal. I have no experience with other machines. Maybe other participants or other presenters have other experiences and can guide you and advise you to buy a machine. I can not do that. It's just what we learned about the machine we put together in the guide. I think the machine is okay, but this is not an advert and it's not an assessment. We are just sharing information. We put on that manual as well. It's available in German, and in case a lot of you contact me that you want to have an English translation, maybe I can reserve some time and make that yeah, in the next couple of weeks, maybe. For the stitching material. The suitability of different materials depends, of course, heavily on the device, on the embroidery machine you use. Some of you may already know that. And in our case, we had some good example using thin but stable fabric, meaning that it's not stretchable. When the material is stretchable, I think that some of you can confirm that the difficulty level would significantly increase. You would maybe need other stabilizer fleece. This is always recommended, using some stabilizer fleece to enhance the precision of your embroidery. And what I want to point out, when you start with turtle stitch and embroidery in general, bobbin thread is different from embroidery thread. I had to learn this the hard way myself. My first results were quite ugly until I learned, okay, you need to use another thread as embroidery thread and not the bobbin thread. The bobbin thread goes beneath into the machine. You can't see this most of the time, and the embroidery thread would be the thing that is visible, that your needle stitches into the cloth. Okay. You need a little bit of practice for everything. You need to learn to know your machine, allow for some trial and error time. To start with, it's probably not as easy, but we will improve very quickly. But maybe don't start with your favorite T-shirt and doing that. Okay, so now I will provide some demonstration, only a couple of things that we think are important for the later discussion. This is not very extensive, it's very quick. Please ask questions. Mareen, you will observe, thanks for observing the chat in case there will be an important question, and just interrupt me when I'm too fast. Okay, when you go to turtlestitch.org, I'm doing that right now, going to the welcome page, changing to this one here. You see a couple of examples here. This is a very nice resource for inspiring yourself what you want to do in TurtleStitch. There are a lot of beautiful examples here, so please have a look. For now, we're going to the place where the action happens, so to speak. We click on the Run button on the top right and go to where I can start coding. Okay, so now on the left-hand side, we see the palette and the categories in which the different blocks are split into. And we can drag and drop some blocks here, move it to the coding area. And when we click on the individual blocks, we see on the right-hand side, on the stage, the turtle does what we ordered it to do. We can snap some other blocks together, maybe use a move 10 step together with a turn 15 degrees, click on it again. And when I do this several times, we'll see it does a little circle. Okay, so when we want to run code again and again, and that's totally normal when we program that we do this, we test our code always when we make changes, we need a reset button. So with this one is in the control category here, we can reset our stage, not our code. Our code is not lost because of that, but we're just resetting our stage. So the thread is gone and the turtle is in the center of the stage again. We can snap this together and execute, and we'll see the turtle does this first steps. So what is very interesting in here in the control category as well is a repeat loop. Let's use this one. We're putting our motion in the repeat loop and say, okay, now you do this motion 10 times. So it starts, it's the start of a circle. When we now adjust our settings a little bit, let's repeat that 36 times. Maybe the angle we turn in, we put in 10 degrees. And when we repeat this, we have a full circle. Okay, so what we also could do from using from the control group is the when green flag clicked. Normally this one signposts the start of a program. After we snapped that on the top of our code, we can now also execute our code from the top right with the green flag and from here. And as said, it's the standard way to start a program, I'd say. Okay, have a look in my notes. Great, this is what you may also use in Snap or other branches. What is very special is the embroidery category in TurtleStitch. So we have here a couple of different stitches we can use. Personally, in this example, I like the cross stitch. I put it right beneath the reset button and before the movement. So I'm setting my stitching settings right before the movement. When I execute this, we see it's exactly the same, but in another stitching. Okay. Then the next thing I want to show is jump stitches. Let's assume I want to start my stitching in the middle of the stage. So now I'm a bit in the lower part here, and now I need to do some motion right before I start. When I do this, let's assume I go 100 steps up on the Y coordinates, put this one together. I would stitch all the way up and then create my circle. That's not what I wanted. I wanted to make the turtle jump. I put this one in here. So not stitch, and it needs to land. For this, I need another stitch. Put this one on false. In my words, I always say jump no means landing. So this one, the red one here, signifies the landing. When I execute this one, my turtle will move up without stitching, then land, and then create the circle we had before. Okay. The next thing that is important for later analysis for the creative phase is how we make a block. We can right-click on the coding area. Then, as shown yesterday in Cynthia's workshop, I always pick motion because most of my blocks are about motion. I say this is a circle, click OK, and my personal block is created. I now could pick from any category whatever I want and put my code together, but I don't want to do that because I already have my circle here. I drag and drop this one in here, hit OK, and now I have in the list on the bottom of the motion category to which I assigned my my block, I have my circle and then can execute this one. Now you don't see any difference because it's exactly the same, but in shorter form, in more observable form. It's much easier to read, but I can put some circles together. Doesn't make much sense now because it stitches 3 circles over each other, but you catch my drift, you see what it does. Okay, so now for variables. Let's assume I want to stitch more of these circles. Again, I pick a repeat loop. Then after each circle, I want to change the angle a little bit. Let's say, again, this is 10, this is maybe 30, oops, this is 36. So I repeat 36 of these circles, and after each one, I change direction 10 degrees. So now would create these. What would be much faster than to adjust these numbers all the time would be using variables. I can show this, I exchange these numbers, so I have a different result, but it always does a full circle and places all the circles very nicely along the 360 degree angle or turn. What I could do now is using variables. I go to the variable category and say, make a variable. I'm now I call this variable number of circles. Okay. It's a bit slow now. Okay, now it's ready. The number of circles is this number I put here. So I replace that one. And what I can replace also is I change this 36 degrees, replace it with an operator, say, okay, a full circle is 360, but I divide it by my number of circles. And so I can, okay, made a mistake somewhere. Oh, yeah, rookie mistake. Of course, I need to initialize my variable. So I need to set my number of circles to any number. Before it was 0 because I didn't set it. Now I can pick whatever, 3 maybe. I pick here turbo mode, so it is a little bit faster. So I have 3 of my circles. Now I can do 6, and it always arranges them very nicely along the 360 degree turn. And yeah, what I wanted to show here is that I set the variable once. Is it used at several places, which in complex programs, it's yeah, of course, it's very faster. They're much faster that way. Okay, that's for my short demonstration. And now we're going to the creative phase for everybody. Go back to my presentation. and we're now going to the examining of the students' learning cards and codes. We will do this in group works in breakout rooms, approximately 20 minutes. Let me check the clock. Yes, it's okay to assign 20 minutes for that. We find some material on our homepage. Mareen, when you can paste the link, or maybe you already have. Very nice. When you go to this site here, you will find a couple of things. Let me show it to you. In the first paragraph, you have a collection of all the material you need right now. So in this download here, you have a collection of all the material. It's a zip file. I would suggest you, you save that zip file to your computer and extract all the content to your computer. When you do that, you can use the code which is in there. The different codes for the projects, you can drag and drop it to TurtleStitch, which is very convenient if you don't want to rebuild the code yourself. In that zip file, all the learning cards for 6 different projects are in there. All the codes are in there, and also the instructions. So you will see these slides here. You will see in the download as well. So you can find these instructions I'm showing at this very moment, if you want to reread them. For the discussion later, I would suggest you look out for the following things and try to answer them if the students explained their code nicely, if it was difficult to understand or if it was easy. Where did the students obviously have problems, or where they did very well? If the explanation on the students' learning cards was sufficient, maybe you do spot anything special on the cards or the code, and which advice you would give the students to improve the description on their cards. Of course, you can also talk about different things in the breakout rooms, but these are the suggestions that I want to give you. So yeah, I will set up the breakout rooms now. Let's see that works. And for the breakout room 1, please work on the project number 1. Breakout room 2 will work on the project number 2, and follow the students' instructions, and yeah, please have fun with it. And when you are finished with one project, then you can decide on yourself. You want to have a look at another project, or can decide as a group if you want to check another project. Just that you know, the lower project numbers are a bit easier. The higher project numbers are a bit more advanced, but I'm sure you will help each other and you will manage. Okay, so then I will stop my presentation so I can create the breakout rooms. Can't see this right now. Fine. Okay, have fun, everybody. Mareen will be in one room and Julia as well, and I will be hopping around and help you in case you have questions. Okay, welcome back. I'm rearranging my screen just now. So now you should be able to see my presentation and the first learning card. Very nice. Okay, I hope you had fun. I hope everyone is back. Yeah, seems to be like it. The breakout rooms are closed now. So yeah, for the discussion phase, I have the question on the screen. I hope you can read it. I hope it's large enough. And the first card is the circle one, exactly. So yeah, if you want to comment, I'm very curious to find out what you found out, what you discussed about this card. You can unmute and ask questions.
Hi, can you hear me?
Yes, yes, we can hear you. Hi, Margaret.
We looked at this, me and Peter, and there's some nice touches to this because they're using a function. They also know enough not to stitch right in the center repeatedly in this pattern. So there's some nice aspects to this person's work.
Yes, exactly. So this person, Sophia, obviously was able to stitch different circles and avoid the density problem in the middle. So that one was very nicely done. Exactly. Anything else? Could you follow the instructions on the card. So that was quite clear in my opinion. I think that was very good to follow, very easy as well, and well explained where the difficult parts are, right?
Yes, it was. And it was lovely that they put their name on it as well. So they were pleased with it, yes.
Exactly, yeah. So the circle parts, of course, were demonstrated in the course, but yeah, a lot of them also included some individual aspects, and yeah, a lot of them put in their names as well. So when I studied this card, well, what I realized and found very good, the reset blocks are used correctly. It's the reset blocks are put in as a start, then defining the stitch type was done very nicely. What I found in this one is that one circle was created by mistake, so it's run too much. It's not a big issue, of course. Kids are learning, but yeah, it's something Sophia didn't notice as well. But otherwise, it's a really nice example. She was using the personally defined blocks properly and everything. I really liked this example, especially because yeah, Sophia was a little bit afraid and insecure to program, and she also expressed that during the code. This is what you couldn't see from the learning card, but when I pointed out now, but in comparison to the result, I realized later that Sophia did exceptionally well. It was a very good example. It was nicely done, diligent and everything. So this was really nice work of Sophia. Yeah, you want to point out anything else?
Well, who cares if there's an extra circle? I mean,
yes, exactly.
It doesn't stop. It isn't if it's essential to that design, nor
Absolutely.
does it cause an error message of any sort. There is one example, the flower, where the center had too many stitches in it, and there was an error message. And I wondered if there was a problem. Often there isn't a problem printing, even though you get the error message. And I was just interested in, I would never mention to this child that there's a circle. Hooray, is what I would say.
Yes, no, I'm totally with you, Cynthia, totally with you. I didn't point it out to the student. It's just what we realized afterwards when we studied the card. As you can see, it is a bit dense here in this flower example. Very, very well spotted.
There is a red mark in the center.
Exactly.
And there is a density warning when you run it.
Yes, exactly.
I did both. And I just wondered what the author of this flower thought about density warnings.
Yes. We discussed this in the workshop about density warnings, to be careful not to have too many stitches at one spot. It could be even dangerous when the needle breaks. You could hurt yourself. And this is what we discussed.
It's hard to remember discussions.
I'm sorry?
It's hard to remember discussions. I'm just wondering after it happened whether she had
We saw in this example it's not too serious, so we had a look at it and decided to stitch it anyway, and we could more or less guess that it would work, but we discussed it and pointed out to the students to be careful in other examples and really not to overdo it with density warning and ignore it too long. So so this worked out pretty well.
And I have
of the density warning.
I have another question, but I have to find it. There was one that had I think what they did is wonderful. And I'm trying to, the one with M logo. That's a lot.
That's a lovely one.
It is, but there's a lot of changing of the satin stitch, and I wondered if it showed up.
Yes, actually, that part with changing the setting stitch, I really like that. The student was very diligent to try everything in TurtleStitch. Was amazing to see, and that part with the changing setting stitch was this one here. When you can see you should be able to see
Wait
my
a minute.
mouse cursor.
I'm looking at in the preview. I have to come back to you. Yes,
it's
this
the
one.
first. It's the first part of the M that gets bigger and bigger. So that was the effect when you execute the code step by step. So you can see that it's getting bigger and bigger. And I really like that example of just playing and fiddle and checking with different settings. Yeah, it was nice. Yeah,
She
exactly.
really was, or he, whoever it was really involved.
Yes. It was the only example that used different colors. So that was very exciting as well for me to see. Also the nesting of different loops into one block was very nicely done here, avoiding the density problem. So yeah, this student was very diligent to find out everything about TurtleStitch and couldn't stop. So at 4 o'clock to tell them.
Lovely. It's lovely.
One question on this one. When they changed the color, how do you have a sewing machine that can achieve that? I know mine. It would take me 20 minutes to.
Yeah, it would have been the same problem with us. As you can see on the result, we decided only to pick one. It was very unfortunate. We had different colors, but time was running out, and we needed to skip that. It would actually stop when you assign a new color. The machine would stop. It would recognize that, and you would have to change the thread by yourself. We don't have such a large machine that uses different colored threads. That would be nice, but would be a bit expensive, I think.
Using variegated thread would make it very interesting too.
Okay. Honestly, I don't know what that is.
Variegated thread would have that effect. It's got different colors in the one thread.
In the one same thread. Okay, yeah, that would be a great example for this one. Yeah.
Yes.
Okay. Good. Have you other statements? Maybe we already discussed the circles. This one here was quite a nice one as well. Let me see on my notes. Yeah, that's
Andrea is showing some thread there. Is that this kind of rainbow thread?
Nice.
Can you see it? It's one possibility to change the color and not to having to rethread the machine all the time.
Okay, very nice. Thanks for showing. Yeah, that's a very nice example. Okay, any other projects you want to talk about? Something you realized?
Well, for this project, I'm sorry.
No, just continue talking about the projects. I just wanted to say that I really like the setup, but I came so late and we had to discuss it in the breakout room. So you have teachers who are students who are future teachers, right, and who are working with younger students in a classroom setting.
And not exactly in this example. It was students from lower secondary school, but the learning card example we picked because we wanted them to express and explain their projects. That was the setting.
How much time? Was this all done in 20 minutes, or how much time did these young people have?
It was a full day. It was a full day. So in the morning, explanation, training, be creative with different examples, and in the afternoon, creating the project and stitching it, and describing the learning card.
They must have been tired.
Yes, it was exactly. This was one thing we experienced. It is long, an entire day. I mean, it's very nice situation to have an entire day for TurtleStitch in a classroom, of course. I'm not complaining, but it is long to teach in one go, right? So when you can plan in a lot of breaks, maybe you can go to the experiences we gathered. So
I have one other comment that the young person that made the ice cream cone thought it wasn't very much in its cone.
In her opinion.
In her opinion, yes.
Exactly. Yeah. Right. That's
I thought that took a lot of information to put that together.
Very well spotted. This is another example of a student that was a little bit intimidated about her ability to code, and she was feeling very insecure. This was something we observed in the entire group. I can only speak for our workshop, but in general, in our workshop, the girls were a little bit insecure, but the results were very, very good. And a lot of the boys were quite, it was too easy. And the results were, not very difficult, honestly. Again, I can only speak for our workshop. It doesn't have to be repeated in others, but it was an interesting observation that the girls did very well, but were quite insecure. Yeah, very well spotted, exactly. I mean,
I'm not sure if I'm sorry, Bea, to interrupt, but
no
I
problem.
think there was another question by Simon Wong, if I got that correctly.
Simon, you want to unmute? Or can you read it out loud? Is it in the chat?
No, he just raised his hand, or at least I thought he did. Maybe it was just another gesture. I just.
No. I mean, I can draw it in a one-stroke painting.
Oh, that's what you were doing.
Yeah. I'm drawing in one-stroke painting, and I can do that in TurtleStitch too.
Okay, maybe one. If you want to comment, do so. One I wanted to point out. It's it's also the number 6, so it's the most difficult one of these, the most advanced one. I really liked this example here because it used personal blocks. It even nested personal blocks. I don't know if you realize, but this block here is called stars, so plural. And nested within are other blocks called star and reused. So this is a very nice example of nested coding of personal blocks. And I think this one was a really advanced one. And I really liked that one. Yeah, was a nice idea. Having a tree with stars in the background, and this was one of the students who took very long to with the cloth and make it beautiful with the scissors, cutting all the jump threads. And this is one example of a student. When we were finished and we had to go home, everybody, she didn't really want to leave the room and wanted to go on stitching. And when I told her that I leave the stitching machines at her school, her eyes went like this and were sparkling in all colors. It was really nice experience, and she was very happy to have been introduced to TurtleStitch. That was really nice.
And was she experienced in coding already? So because it's not that self-explaining to create your own blocks.
Exactly.
I mean, as good as Snap is, but it takes a little while.
We explained the procedure and the concept in our workshop, so she knew about creating own blocks. And but the nesting, I can't recall that we showed it, Mareen. We had no examples of a nested personal block, so she did that on herself. Obviously, she had some experience. All of the students had a little bit experience with Snap before, but most of them commented that it was too difficult, and so the start was a bit rocky, so to speak. But after a couple of minutes, they realized, okay, we can create something. We can have a physical result, so it went quite went quite nicely after that, after they realized this. Okay.
Natalie just posted a picture in the chat. Maybe do you want to comment on it before we have to wrap up this session, as our time has already run?
Yeah.
I need to.
Une photo, ils sont en train de regarder la photo que tu as postée. Si, je viens de te dire que si.
Let's see if I can open that. Okay, not sure. Can you comment on that?
Yes.
No, I just wanted to say that Cynthia's flower reminds me this flower, which is inside the book Mindstorm from Simon Pecker. I can show it to you. Where is my? Just, sorry, this book.
No problem.
Okay,
no.
that's all. That's all.
So there were
Thanks for sharing. Thanks
a lot. There were quite a lot of examples in there that we could try using TurtleStitch. Yeah. Good. Okay, so yeah, then just a thing or two that we experienced in the class, in the workshop. Keep the demo phases short. It's much more rewarding for everybody involved when the creative phases are large and they could just try whatever they want. They learn much more than with a lot of theoretical blocks. In our workshop, I already pointed it out that the girls were a little bit insecure, but the results turned out to be fantastic. And handling the embroidery machines takes up a lot of teacher time. In our course, it took up a lot of my time and couldn't coach the students. Fortunately, I had two helpers with me, Mareen and the class teacher who were helping. Don't underestimate that when you have to prepare the material all the time for so many students at once. And try to involve advanced students that are very diligent and especially very careful with the machine, because it can be dangerous. So when you have students who are able to do that and work carefully with devices as such, you can involve them and they can help you with such workshops. When you plan in an entire day, split into several sequences, as said, it is long, one entire day. It can't sink in, so to speak. So planning a lot of challenges and a lot of breaks, for instance. And another thing would be you can change your setting and maybe have a couple of hours a day and spread across a couple of days. That would be very nice as well. Exporting data to the memory stick was not easy for all the students. So we even realized a very diverse level of previous computer science knowledge. So when you, this further highlights the importance of the creative phase when you have longer blocks that in which students can be creative. It's much more rewarding. You can help the ones that are not as proficient in handling the computer and let the others be creative that are more advanced. Okay, so the last program for today wants to thank you, everybody. It was very nice, very nice input from all of you. I hope I will see you again, maybe in other workshops or in person maybe. And thanks a lot. Have a nice day and enjoy SnapCon. Okay, thanks.
Bye, everybody. Thank you.
Thank you, B. That was wonderful.
Thank you.
Thanks, Rowdy. Thanks.
Thank you. I do the project, the ice cream.
Nice.
My question on this, you didn't print it in size 1 on a machine.
Yeah, that was a mistake. I wanted to stitch this one on before the course, but I ran out of time. So
I hope you work with a lot of children in the future, young people in the future. Yeah. You're wonderful. Thank you. Bye.
Thanks. Thanks to you too.
Thank you.
Thank you. Bye.
Thanks.
Bye.